Hello, seekers of truth. Welcome to the lesson on the mean value theorem and Rolle's theorem. And in this video, we are going to look at some examples or an example of how these theorems can apply. Okay, and so let's look at this problem statement. Two bicyclists begin a race at 8 a.m. They both finish the race 2 hours later. Prove that at some point during the race, the bicyclists are traveling at the same velocity. Okay, so and this isn't entirely obvious or clear why this is true. So you have two people in a race, they run it, it's a tie basically, and one of them could be running faster than the other at some point, the other could be running faster than the one, but this is saying that at some point, at some instant during the race, they are both running at the exact same velocity. Okay? And so let's try to just diagram out how this works, kind of a graphical representation of this, and then we can actually get into the proof. Some basic things here. I've gotten my axes drawn. On the horizontal one, it's time in minutes, and I'm going from 0 to 120. In the vertical, this is the distance from the start. Okay, S1 is going to be the function that represents the position of the first biker, and then S2 is the position of the second biker. Okay, and let's, for the sake of just the problem, I'm just gonna kind of make this up because I really don't know too much about what these guys are doing. Let's pretend for a minute that biker 1 starts here at the starting point, and let's say he starts out really fast, so his slope is increasing or very steep, and then he kind of levels off a little bit, and this is the finish line. Okay, this is the finish line. All right. Now, biker 2, what do we know about him? Well, we know that at 120 minutes he ends up at the same spot, but he can do some other things. Maybe he starts out very, very slow, gets fast, and then levels off a little bit here, and then he kind of reaches at that point. Okay, so I don't know exactly how these guys travel. Maybe we'll make it this a little bit more interesting. Maybe he doesn't quite get there in that way. Maybe he gets fast, levels off, gets fast again, levels off. So maybe, and I'm totally making this up because I don't really know what happens in between. Okay, we really have no idea what's happening to these bikers in between the start and the finish. We just know that they start at the same time and they finish at the same time. Okay. So with that in mind now, let's look at something else. Let's look at the distance between the two guys, because these are position functions. We want to show somehow that the velocity functions are equal at some point. So I've made a new function here. I'm going to call d of t is equal to s of t, or s2 minus s1. In other words, where is biker 2 with respect to biker 1? Okay. Now, all I really know is, again, they start out at the same time, so their distance from each other, at the same spot, so their distance from each other initially is 0, and at the end of this, their distance from each other is 0, because they finish at the same spot at the same time. Okay? But in between here, well, I don't really know. Maybe initially biker 2 is behind biker 1, so this is negative. Right? This is negative. It's very, very biker 2 is still behind him, so this is negative most of the way. And then maybe at the end they finally catch up, and finally biker 1 or biker 2 kind of, maybe he gets ahead of biker 1 a little bit, and then they catch up and they finish there. Okay, so we don't know very much about what these guys are doing, but we do know that the distance between them is going to look something like that, because biker 2 is trailing most of the way, and then he sort of catches up at the end. Okay, and more importantly, we know that here d of t is equal to 0. In other words, d of 0 is equal to 0, and over here d of 120 is also equal to 0. Okay? Now, what this tells us then is that there must be a point in here where the tangent slope is also 0. Okay? So there's got to be some point in between there where the tangent slope of the d function is equal to 0. So there must be some point here, right, at some point in here, the tangent slope's got to be equal to 0. So we'll call that point C. So this is Rolle's theorem. Okay. There exists a time C in between 120 and 0 where d prime of C is equal to 0. There's got to be a point like that. Okay, so there's got to be such a point. All right. Now think about this for a moment. This is saying something pretty important. A time C here. That's the magical time, whatever that is. Okay. Well, let's take this to its logical conclusion. So d of t. Remember that d of t is equal to s2 of t minus s1 of t. Okay. And so what that means is that d prime of t must be equal to s2 prime minus s1 prime. Okay, so this is just some basic derivative rules there. Okay, but we do know that d prime of t is equal to 0, so d prime of c, is equal to 0. Okay. But that's equal to s2 prime of c minus s1 prime of C. All right. Get my parentheses and my C's here correctly. So we continue with this part. This part right here, right, tells us then that S2 prime of C equals S1 prime of C. In other words, at some point C, the derivative of the position of biker 2 is equal to the derivative of the position of biker 1. Okay? So we can finish out by saying, well, really, S2 prime of t is the velocity of biker 2, and S1 prime of t is the velocity of biker 1. Okay? Therefore, C is the time where the velocities are equal. So C is the time where the velocities are equal, because by Rolle's theorem there's got to be a point C such that the derivative of d at C is equal to 0. And if we make just these substitutions in here, then what that says is that at some point C, 0 is equal to S2 prime minus S1 prime. So that means S2 prime has to equal S1 prime for some point C. Okay? So again, the statement of the thing we're asked to prove isn't entirely obvious. We wish we could say that must be true, but it isn't necessarily so. But here we prove just that it must be necessarily so. Okay? Now, some questions for you to think about. So answer these ones on your own. Okay, think about this. I'll make a little box here, and I guess this is really one answer, one question. What assumptions were made about S1, S2, and D of T? Okay, S1 of T, S2 of T, and D of T. What assumptions were made? So think about this. I made some assumptions here, and I purposely didn't say anything. And I want you to think about it, and we'll talk about it in class regarding what exactly were the assumptions here. Because Rolle's theorem doesn't always apply. There's a certain conditions that has to be true in order for this theorem to work. Okay. Well, thank you for watching. Have a wonderful day. Keep working and keep thinking about these higher level concepts.